All right, Math 10C, I've got exponents lesson number 3 up for you here, integral exponents. I'm going to walk you through the notes and a couple of class examples, and then we'll end off with assigning some homework. So this will replace me being in the classroom today. All right, so let's get started. So similar to our pattern for the power of 0, we're going to try to develop a pattern for the negative exponent. And so I'm going to start with the powers of 10, and probably will leave off only with the power of 10, just to show you what we can expect to happen when we see a negative exponent. Okay, so if we start here, 10 cubed, or 10 to the 3, 10 times 10 times 10 is 1,000. And now when I go down an exponent, it actually results from dividing by 10. So instead of 10, or 3 factors of 10, I have 2 factors of 10, or 10 squared. 10 times 10, which is 100. And then I keep that pattern going. I divide by 10, and I will get down to 10, 10 to the 1 being 10. And I divide by 10 again. I will get to my power of 0. 10 divided by 10 is 1. And then notice how I was going down the exponent here from 3 to 2 to 1 to 0. I was going down by 1 each time, and each time I go down by 1, I'm dividing by 10. So it makes sense here. If we're going to make that jump from 0 to -1, go down by 1, we're going to divide by 10. So 1 divided by 10, which is 1/10, or we could represent it as 1 over 10 to the 1. And then I have to divide by 10 again and make that jump from 1/10 to, and I go 1/10 divided by 10 will give me 1/100th, or recognizing that 100 is 10 squared, 1 over 10 squared. And just to verify the pattern one more time, I'm going to divide by 10, and when I divide by 10, I'll get 1 over 1,000. So 1/100th divided by 10 gives me 1/1000th, and 1,000th is 10 cubed. So this is like 1 over 10 cubed. And so if we're going to make a pattern, we're going to say, well, a to the 0, anything to the power of 0 is 1. When you get into negative exponents, we notice that the base, in this case 10, moves down to the denominator and can be written with a positive power. So a to the -1 would look like 1 over a to the 1, which I would probably just write 1 over a, because we typically don't write the exponent 1. And then we go down, a to the -2 would look like a in the denominator with exponent 2, 1 over a squared. A to the -3 would look like 1 over a cubed. And we're developing the pattern to say a to any negative exponent. You can take the base a, move it to the denominator, write it with the positive exponent, although of the same value, so a positive n, and we are going to write the reciprocal, or the 1 over. Okay, and so write the following with positive exponents. 10 to the -7, well, that would be 1 over 10 moves down, positive 7, 1 over 10 to the 7th. 3 to the -5, 1 over 3 to the 5th. And I, of course, could simplify those. Okay, so using exponent laws to define or to prove this idea of the negative exponents, let's look at similar to an expression, 5 to the 4th divided by 5 to the 7th. So similar to the quotient expressions we've been seeing in the past couple lessons. 5 to the 4th divided by 5 to the 7th. First check. Bases are the same, both base 5. Now if this was the expression, my quotient law, now that doesn't come down into C, quotient law would tell me when you divide powers, you subtract the exponents. And so I would go 4 minus 7 would give me a -3. And I want to prove that that will work. So I go 5 to the 4th divided by 5 to the 7th. 5 4 times on the numerator. 5 7 times. That's 4, 5, 6, 7 times in the denominator. Anytime I have 5 divided by 5, it's going to cancel and leave me a 1. 5 divided by 5 is 1. So I've canceled all my factors up top, so I'm left with a 1. And then on the bottom, 3, 5, so 5 cubed, and 1 over 5 cubed would be 5 to the negative 3. And so the results that we get from this in A to C, I better do A with you. A says evaluate the expression as an exact value using a calculator. So I'm going to pull my calculator up. I'll show you how I type that in. So here's my calculator. So I would go 5, and then here, use my little funny exponent button, 5 to the 4, okay, divide by, I should put this in brackets. Let's try that, 5 to the 4, divide by 5 to the 7th, okay, 0.008, math, fraction that, 1 over 125 would be the exact value. So I've got the 1 over 125. I've got 1 over 5 cubed, which we'd write 5 to the negative 3, which 1 over 5 cubed would be 1 over 125. Again, quotient law proves 5 to the negative 3. And so the results are going to develop for us a general rule. When a base is raised to a negative exponent, a to the exponent negative p is 1 over a, and you make the exponent positive, 1 over a to the p. Write the following with positive exponents and evaluate. Evaluate means come up with an answer for it. So 2 to the negative 1, I'm going to go 1 over, or reciprocate, 2, and then I write it with positive. 1 over 2 to the 1, or 1/2. 3 to the negative 2, 1 over 3 to the 2. So I move my base down, change the exponent to a positive 2. 1 over 3 squared, or 1 over 9. And 4 to the negative 3, 1 over 4 to the 3. So moving the base 4 down, change the exponent from negative 3 to positive 3. 1 over 4 cubed. 4 cubed is 64. So this would be 1 over 64 as a value. Okay. If you need to pause the video at any time, please feel free, let your sub know, and we can stop it, and you guys can go back and take time to write the notes. Okay, so the negative exponent in the denominator, can we try to prove that 1 over 4 to the negative 3 equals 4 to the 3? Now, I already know, based on what I did on the last page, that this sort of works in the reverse. We said 4 cubed, if this was negative, we would go 4 to the negative 3, and then we would go 1 over 4 to the 3. This is asking for, if this is negative in the bottom, can you move it to the top and make it positive? And so use the rule for division of fractions to show that this is true. Use a calculator to confirm. And so when I talk about this, division of fractions, our rule has been typically multiply and flip, or sometimes you hear it multiply by the reciprocal. I'm not sure which ones you're familiar with, but the idea is if you're going to divide by a fraction, you should be able to multiply by the reciprocal. And so I'm just going to rewrite this. 1 divided by 4 to the negative 3, 1 divided by 4 to the negative 3. Okay, so I'm just going to use the division sign so I can build myself a fraction and I can divide it. Okay, on the past page, we said 4 to the negative 3 is 1 over 4 cubed. So now I've got 1 divided by 1 over 4 cubed. Using my rule for dividing fractions, this is going to become 1 multiplied by 1 over, 4 cubed over 1. Because I got to multiply by the flip, so I change the division sign to multiplication and then flip this fraction. 4 cubed goes to the numerator, 1 goes to the denominator. 1 times 4 cubed over 1, well, that's just 4 cubed. And so we've tried to use the division rule to prove why it would end up being 4 cubed. Let's check it on our calculator. 1 divided by 4, use the same exponent button, 4 to the negative 3. Oops, not 10. There we go. 64. And because 4 cubed is 64, we could say we've used a calculator to confirm that this is true. And so it works both ways. If you have a negative exponent, it goes down into the denominator, can be written with a positive exponent. If you have a power with a negative exponent already in the denominator, you can move it up to the numerator and typically over 1. So we say this is almost like all of our other expressions on one line, a to the n. And we're just going to put in this extra bit here. So this right here, a cannot be 0. It shows up here as well. That bit there is just to say you don't want or you cannot divide by 0. So let's just make sure that that base is not 0. So it works for all bases except for 0. Okay, so go through a couple of class examples here. Class example number 1, simplify, express with positive exponents, and evaluate without using a calculator. So simplify means apply an exponent law, express with positive exponents, use some property I used today or learned today to try and write that with a positive exponent, and then to actually evaluate. And so 4 to the 5th times by 4 to the negative 3. Powers being multiplied. So product of a power, when we multiply, we can add 5 plus a negative 3. 5 plus negative 3 is a positive 2. So this is 4 squared, or 16. And it's already written with positive exponents, so I could kind of skip that second step. 3 squared times 3 to the negative 5. Again, if I add 2 plus negative 5, 3 to the negative 3, that's simplified. Express with positive exponents means translate this into 1 over 3 to the 3, using the rule that base 3 could be moved into the denominator, and that would make that exponent negative 3 positive, and then simplify or evaluate. 1 over 3 cubed will become 1 over 27, since 3 cubed is 27. Okay, 1 over 2 to the negative 5. Now I could simplify, but I already have a rule right here. It looks very similar. When you have a base in the denominator with a negative exponent, you can move it up and write it with positive exponents. So I'm going to do that here. I'm going to move the 2 up, write with positive exponents. It's going to be 2 to the 5th. Evaluate. 2 to the 5th is 32. Okay. Right here, 6 to the negative 7, divide by 6 to the negative 5. I like to see this division symbol as a subtraction symbol. When you're dividing powers with the same base, you subtract the exponents. 6, and then I got negative 7 subtract negative 5. I'm going to just write that over here. Negative 7 subtract negative 5, so that you can see that when you subtract a negative, that double negative is like adding the opposite, add a positive 5. So negative 7 plus positive 5, that means this is negative 2. 6 to the negative 2 is simplified. Express with positive exponents means move the base to the denominator, change the negative 2 to a positive 2, 1 over 6 squared. I'm going to lead into the next question a little bit. 1 over 36, and 6 squared is 36. The very last one, E, I'm just going to carry this example on up here. 2 cubed to the negative 1. Power of a power tells me that that negative 1 would get shared inside, and when it got shared inside, it would multiply. 3 times negative 1 would give me a negative 3. That's simplified. Express with positive exponents means move the base to the denominator, change the negative 3 to a positive 3, and then evaluate. 1 over 2 cubed. 2 cubed is 8. So this would be 1 over 8. Identify the following as true or false. 8 cubed divided by 8 to the negative 1, would that actually equal 8 to the 4? Just want to do a quick verification for myself. Dividing means subtract. Checking 3 subtract negative 1, is that positive 4? Yes, because again, when I do 3 subtract negative 1, that double negative will turn into that positive. It turns into positive 4, and so yes, that's true. In B, 8 cubed divided by 4 to the negative 1 equals 2 to the 4. Oh my goodness, what are they doing here? 8 divided by 4, bases are not the same. As soon as bases are not the same, I can't do anything with that. That's false. So I'm not even trying to do the math here to see what the exponents is correct. It looks like they did get their exponent right, but you cannot divide bases that are different. Bases don't divide. Coefficients divide. Bases don't divide. Okay, a to the negative 3 equals 1 over a cubed. Okay, I had that rule right up here. A to the negative n, so in this case negative 3, you can move it to the denominator, make it positive. So that's true. D, oh, this one's a good trick question. 9a to the negative 3 equals 1 over 9a to the 3. Okay, remember that conversation we had about what was the base and what was the coefficient? And I know that that 9 is a coefficient, which means the exponent here does not go to the 9. That's only on the a. So if that exponent is only on the a, that a to the negative 3 is the only thing that should be moving. So this is false. I should not move the 9. In fact, the 9 can stay in the numerator or stay up top where it is. A to the 3 can go to the bottom, so a to the negative 3 can be moved to the bottom and cubed. And so that is false. The correct answer would be 9 over a cubed, where the coefficient is still 9. Now that power, they were implying or intending for us to apply that to the 9. That would definitely have to be in brackets. So the coefficient stays, only the power gets the rule. Okay. Simplify and write with positive exponents. A to the negative 4 multiplies with a to the negative 3. Multiplying means add the exponents. I see they're separate, so it's not power of power. A to the negative 4 plus negative 3, a to the negative 7, write with positive exponents, moving it to the denominator, 1 over a to the 7th. 6x squared divided by 2x to the 7th. Okay, so numbers divide by numbers. 6 divided by 2 is 3. X squared divided by x to the 7th. When I divide powers, I subtract the exponents. 2 minus 7. 2 minus 7 is a negative 5. Be careful. That's a coefficient. Only the negative 5, or the negative 5 exponent is only on x. So I'm going to leave the 3 alone. X to the 5th moves down into the denominator in order to write with positive exponents. Y to the 6th divide by 2y to the negative 5. Again, the negative 5 is not on the 2. The 2 has to stay where it is. Worry about your powers. This is division. Division means subtraction. Y, 6 subtract negative 5. Well, I'm subtracting a negative, which means I add the positive. 6 plus 5 is 11. It's positive and it'll stay up top. Now, if that was negative, I would keep it in the denominator. Or I would move it to the denominator and make it positive. So it's already positive. It's going to stay up top. The 2 has to stay on the bottom. So y to the 11th over 2. So that you could think of that as 6 minus negative 5. The exponent's already positive. You didn't have to move it to change the sign or anything. So it stays up top. Negative 2x to negative 3. This is the case. There's my brackets. That can get shared with both. So I've got negative 2 to the negative 3, x to the negative 3, and if you're you don't want to use your calculator, you're gonna have to use your calculator if you don't want to try and do this in your head. So on the calculator, negative 2 in brackets to the negative 3, negative 0.125, I'm going to fraction that. Negative 1/8. So negative 1/8 is my coefficient. X to the negative 3. X has a negative exponent, which means I can move it down to the denominator and make it positive. And so it's going to look kind of funny when you leave it out like this, but remember that it could be represented as negative 1 x to the negative 3 over 8. Okay, it's the negative 1/8 coefficient goes, it can kind of be written as a fraction, all with x in the numerator. So when I move it down, it's no surprise I should leave the 8 there. Okay, that one's tricky. This one, 8a to the negative 5 divided by 4b to the negative 3. Numbers divide by numbers. 8 divided by 4 is 2. a to the negative 5 divided by b to the negative 3. Okay, dealing with these separate. They're not the same. I'm not going to add, subtract any of the exponents there. The bases aren't the same. One is base a, one is base b. But I do know if I move a down, it will go positive. And if I move b up, it will go positive. So that's what I'm going to do. I'm essentially going to switch them and make them positive. 2b cubed over a fifth, or a to the fifth. Okay. This next one here, 5p to the negative 2 divided by 5q to the positive 4. Okay, so I've got to share that negative 2 first. As soon as I see it's outside the bracket, I have to share it. So I got 5 to the negative 2, p to the negative 2, all over 5q to the fourth. Now, both of these have negative exponents. I'm in fact going to move them down so they're positive. And when I move them down, I can't just leave a 0 up top. I have to leave a 1. So now I've got 1 over 5 squared times by 5 times by p to positive 2 times by q to the fourth. And so I'm going to put the 5 squared and the 5 together. 5 squared is 25 times 5, or 5 squared plus 5, times 5 to the 1. 2 plus 1 is 3. 5 cubed, 1 over 125 p squared q to the fourth. Okay. Again, if you want to go back, pause, re-listen to any of the examples, please let sub know and they can do that. Okay, this question looks hard. Simplify and write the answer with positive exponents. Lots of negative exponents in here already. And so I can simplify first, or I can deal with the negative exponents first. Either way, in my final answer, I need to have it in simplest form, which typically means a coefficient, 1 power of x, 1 power of y, 1 power of z, and no negative exponents, positive exponents only. Okay, so I'm just going to look across here. I definitely want to deal with those negatives first. Okay, and a couple of them are drawing my attention. That y to the negative 8, the z to the negative 2, this z to the negative 1, and that y to the negative 3. And I know that if I switch those terms individually from their numerator into their denominator, or vice versa, the denominator into the numerator, that they would go positive. And so I'm just going to rewrite this with applying that rule. So I got 5x cubed, leave it alone, but y to the negative 8 and z to the negative 2, I'm going to move down into the denominator and I'm going to write them positive. So I've got y to the 8th, z squared. Now this is a division sign. I'm going to keep that in place for a minute. Dividing by 15x to the 8th, I'm going to leave. Y cubed, I'm going to leave. It's positive. Z to the negative 1, I'm going to move down. So I'm just going to add it in at the bottom here. On the bottom, x to the 5th, y to the negative 3. Okay, I'm going to move that y to the negative 3 up. Becomes y cubed. And I also had a z squared already on the bottom. Okay, and so this is not a mistake. I didn't accidentally write y cubed twice. Y cubed was already there, plus there was 1 in the bottom, y to the negative 3 that I've moved up to the top. Okay, let's simplify what we can, because I've got times here where I've got some z's side by side, some y's side by side. So I'm going to keep working. I leave the first term alone. It looks pretty nice. There's no double x, no two terms of x, or no 2 powers of z. I'm just going to leave it where it is. Dividing by 15 x to the 8th. Now y cubed times y cubed, I'm multiplying powers. I can add the bases, or sorry, add the exponents, not the bases. Bases are the same. Add the exponents. 3 plus 3 is 6. All over x to the 5th. Z 2 times z 1. So z squared times z. Bases are the same. Add the exponents. That makes a z cubed. And I realized here I had another term with x I should have dealt with. Let's do that now. Feel free to take up some room on your next question. Dividing by 15. Okay, the only thing I'm going to do in this step, x to the 8 divided by x to the 5th. I'm dividing powers. That means I can subtract exponents. X to the 8th divided by x to the 5th will be x cubed. 8 minus 5 is a positive 3. I leave it up top. Okay, so really the only thing left in the bottom is that z cubed. Now this looks really nice. If this was a multiplication question, I would just go top to top, bottom to bottom, and simplify again. But it's division. And we said earlier, if you divide by a fraction, you multiply by the flip. So I leave my first term, y to the 8th z squared. Change it to multiplication. Now again, I like the dot because that looks like x. Change it to multiplication and flip it. Z cubed over 15 x cubed y to the 6th. Okay, that was a lot. All we did in that step, multiply and flip. This is a z, not a 2. Okay. Now I can work to simplify. I'm going to try to do this almost in one step, and I'm going to go in the order that we have been going in. Numbers divide by numbers. 5 divided by 15. Now 5 divided by 15 on the calculator will give me 0.3. I can fraction that to 1/3, or I could imagine it as dividing them both by 5, leaving a 1 up top, leaving a 3 on the bottom. So 5 divided by 15, we've dealt with that. X cubed divided by x cubed is 1. Essentially cancels, or x 3 minus 3, which would be x to the 0, which is just 1. So I've already got a 1 there, so don't need to write it twice. Now I've done the numbers. X, y next. Y to the 8th times by y to the 6th. Multiplying means add. 8 plus 6, that makes 14. I've left it in the denominator because that's where it was. And then my z cubed divided by z squared. When I divide, I subtract. 3 minus 2 leaves 1 z with positive 1 exponent, or can go up top. I did not need to write that 1, so I see z over 3y to the 14th would be my final answer. Okay, we're almost done here. I know this has been quite a long video, but let's keep going. So 2p to the negative 3. Explain why 2p to the negative 3 does not equal 1 over 2p cubed. Now, I made a big deal about this on the last page, that the 2 is a coefficient. And the exponent, negative 3, does not apply. The correct answer would be to say 2p to the negative 3, leave the 2, feel free to move the p to the negative 3 down to the denominator, write it with positive exponent 3, and so it would equal 2 over p cubed and not 1 over 2p cubed. Okay? Consider the expression 2/3 to the negative 4. Okay, this is just going to go through with some fractions. In general, again, your rule is down here. It says you could take some fraction with a negative exponent, but after we share that negative exponent and then try to switch things, it essentially turns out that we could just flip the fraction and write it with positive exponent. So that's what I'm going to be working with here. So if I'm looking at 2/3 to the negative 4, complete the following. 2/3 to the negative 4 means I could move the base 2/3 down to the denominator, write it with positive exponent, which means I now essentially have 1 over 2/3 to the 4th which when I multiply, when I divide fractions, 1 over 2/3 would be like 1 times by the flip, 3/2 to the 4th, and 1 times 3/2 to the 4th would be 3/2 to the 4th. Evaluate 3/2 to the 4th. 3 over 2 to the 4. Bring that down so you can see that. 3 divided by 2, the fraction, exponent 4. I'm going to fraction that. 81 over 16. And so I could almost go in, I'm going to go in and add some detail into A. Where I had 2/3 to the 4th, I want to make the comparison here. 2/3 to the 4th. I'm guessing this is 16 over 81. Okay, so that would be like 1 over 16 over 81, which would be 1 times flip 81 over 16, which would be 81 over 16. And so I only do that because I wanted you guys to see this, how 2/3 to the 4th. If I had done 2 to the 4th, I would have got 16. And 3 to the 4th, I would have done 81. And then we've essentially flipped it when we had the -4. So we flipped the fraction, and it turns out the answer is 81 over 16. And so it's just saying classify the following as true or false. 2/3 to the -4 equals 3/2 to the 4. That's true. And suggest a quick method for evaluating a fraction with a negative exponent, such as 5/2 to the -3 without using the calculator. And so our quick method, flip the fraction and change the exponent to a positive. All right, that was a long lesson. That's lesson 3, integral exponents. Integral meaning integer, dealing with positives and negatives exponents, which we have done. Our general rule, if you have a negative exponent, you can move your base to the denominator, make it positive, and again, vice versa, it works. If you have a negative exponent in the denominator, move it up to the numerator, and you can make it positive. All right, thanks for watching.